This is Utah Middle School Math Project 1.1a, which is on simplifying linear expressions. The first thing that I want to talk about is this word right here, because we have been simplifying expressions. We've done that the last couple days, but this is a new word, simplifying linear expressions. Linear expressions refers to x. What I mean by that is when we had our algebra tiles, we had algebra tiles that included x, we had algebra tiles that included units, and if it is a linear expression, it is only using x tiles, positive or negative, that's fine, but it's using x tiles and it's using unit tiles, positive or negative is fine. It is not going to be using the x squared tiles. So this is our x squared, and if it's using x squared anywhere in there, that is not going to be a linear expression. So that's just an official fancy word saying we're only going to be using x tiles and unit tiles when we're looking at these types of expressions. Anything bigger than that is going to be considered something else, and you'll be dealing with those in future years. But this year we're focused on linear. So to get started, we have this context. Emma is playing a popular video game and is determined to beat the high score. The game saves her place so that each time she plays it again, she picks up in the same place with the same number of points. Emma downloads the video game on Monday night and starts playing, scoring a bunch of points. Doesn't tell us how many, it just is a bunch. But on Tuesday, remember, she's picking up where she left off. So she already has that bunch of points, but now she's scoring an additional 500 points. And on Wednesday, she doubles her score from the previous day. Remember, every time we're picking up where we left off. So same number of points, but now on Wednesday, she's doubling that score. On Thursday, she scores the same number of points that she scored on Monday, but remember, we don't know what that is. It's just a bunch of points. So Miguel's teacher asks him to write an expression that represents Emma's total score after she is done playing on Thursday. This is the expression that Miguel writes. 2, and then in parentheses, we have p plus 500, and then plus p at the end. Miguel's teacher lets him know that his expression is correct. So let's break it down. Let's write in words what each piece of that expression represents, starting with, as we always do, with the order of operations, grouping symbols. We have the grouping symbols and we have p plus 500. What does that represent? Talk with your groups and then move on to the next one. There's a 2 on the outside of those parentheses. What does that represent? Then there's a random plus p at the end. What does that represent? Talk with your groups. Fill in what each one of those represents. I'm going to pause the recording as students have this discussion. Hands. What are our responses now that we've talked with our groups? Please get us started. Timothy. This p plus 500, what does that represent? Say that one more time. The points plus what? Yes, so what does that p represent then? The points on Monday, exactly. Because Monday it says scoring a bunch of points. We don't know what that is. So the p represents Monday. And the plus 500 is because on Tuesday it was an additional point. So Monday plus Tuesday score. Or in other words, p plus 500 altogether is her score at the end of the day on Tuesday. Then we have the 2 on the outside. What is the relationship between the 2 on the outside and the parentheses? Ethan? Exactly. So recognizing that the 2 next to the parentheses means we're multiplying by 2. So why are we multiplying by 2? Because she doubled her score on Wednesday. So this is the doubling of the score. Or in other words, this is Wednesday end of day score. Well, we'll just say doubling of scores because it doesn't show the whole thing altogether. And lastly, this plus p. What does this plus p at the end refer to? Siley? Yep, this is Thursday's because, as it says, Thursday scores the same number of points on Monday, which we don't know. So this is Thursday's addition to the score. So moving on, Nevaeh writes this expression to represent Emma's score on Thursday. The teacher lets her know that she is also correct. How did Nevaeh represent the problem differently than Miguel? They both have it correct, so how is Nevaeh representing it differently? Try and use words to describe what she's doing, as well as making those connections mathematically. Again, a discussion at your tables, and we're going to pause the recording while that discussion happens. Ready, set, go. I'm interested to hear about that. Okay. How is this different? What's happening? How is she representing it? Thank you. I love to see all of these hands. Maverick. Okay. So I think that the reason you're struggling with this P is because you perhaps maybe misinterpreted this 2P. So let's go to Jaden, who is raising his hand so patiently and calmly. Yes, it is simplified. In which way is it simplified? I'm going to scroll up so that we can see Miguel's. In which way is it simplified? Yes, it takes care of the doubling part. What we're doing here, what is the name of this? We saw this from our lesson yesterday. What is this called, Sam? You have your part 2 in front of you still. Because I just checked everybody's lesson. What is that called? What did we do yesterday? Because yes, it was simplified. Sort of. It was mostly simplified. Yes, it's the distributive property. They distributed. They took care of this doubling. And they took care of that doubling by saying, hey, if it's 2 groups of P and 500, that means it's 2 groups of P. Right there. And it's 2 groups of 500, which is 1,000. So they took care of that doubling. Let's write that down because that is important. Did they do anything else? No, Nevaeh still just has her plus P at the end. So really, the way that Nevaeh represented it differently is that Nevaeh took care of the doubling. Now, clue me into that debate that was going on up front that was very heated up there. What were you guys talking about? Siley? Okay. And didn't Miguel's teacher say that they are both correct? Yeah. So they are both correct. Is one more correct than the other? I would say no. However, Jaden, go ahead. Exactly. So they're both correct. Okay. Yes, they both have correct expressions. Is Nevaeh's maybe a little bit easier to look at? Yeah, and that goes right into what this is all about. Nevaeh took one step to simplify. So when we simplify, that's the whole point, is it's easier to look at. It's easier to handle, easier to manage. That is why it is called simplifying, because we are making it easier to look at. And now this leads nicely into part C. Can you think of another expression to represent Emma's score on Thursday? Hint. Although one step was taken to simplify, this is not fully simplified. So can you think of another expression to represent Emma's score on Thursday? Can we make it even simpler? Ethan's ready? Or was that a stretch? Go ahead. What is it? How can we do this even simpler? Exactly. 3P plus 1,000, because we have 2 P's hanging out here and another P hanging out here, so altogether that means we have 3P. That is all the way completely simplified. And again, is this more correct than any of the others? No. Is it easier to look at? Yes, it is. So now we're going to talk about another new concept, which is actually defined on the next page. If Emma scored 700 points on Monday, evaluate each of the 3 expressions above to determine how many points Emma has on Thursday. Evaluate. It's described on the next page, but in short, evaluate means if we know the value of a variable, we're going to use it. We're going to substitute that in. And I will do it here on the easiest one for you, and then you guys get to do it on the tougher ones. So that P is no longer unknown because Emma scored 700 points on Monday, which means in this expression here where it's 3P plus 1000, I'm not going to use P anymore. I'm going to use what P is equal to. I'm just substituting in the value. So P is 700. And this 3P doesn't mean 3 and then 700 or 3,700. It means 3 groups of 700 or 3 times 700. And then we add that 1,000. This is what it means to evaluate. I know the value, so I'm substituting that value in. And 3 times 700 is 2,100, plus that extra 1,000. We now know that Emma has a score of 3,100 on Thursday, according to this expression. So let's have a quick discussion. It says that we need to evaluate each of these expressions. We said that this is correct, and even this one up here, Miguel's, is correct. Are we going to get different answers then? We shouldn't, right? So can you trust me that we don't need to substitute those values into every single expression? Okay, good. Thank you for your trust, and then we're going to talk about that on the next page. So in this lesson, we're going to be studying linear expressions. Remember, linear is just a fancy way of saying we're only going to be using x's and units. Miguel, Nevaeh, and you all wrote linear expressions to represent Emma's total number of points on Thursday. A linear expression, I'm just going to highlight expression. An expression is a mathematical phrase consisting of numbers, unknowns, that's symbols that represent numbers, and arithmetic operations. What's your official definition of an expression? A mathematical phrase. Usually I say it's a mathematical sentence. A mathematical sentence that combines numbers, variables, so that's our unknowns. They're symbols that represent numbers, and various operations, connecting them together with operations. Linear expressions often can describe mathematical or real-world situations. And here are some examples of some linear expressions. Some of them are simplified and some of them are not, but these are all examples of linear expressions. Even just simple 25. Are there any operations? No. Are there any unknowns? No. But it has a number, so this is a very, very simple expression. So simple that sometimes we don't even consider it to be an expression. Okay, next slide, next screen. We also have below some equivalent linear expressions. These equivalent expressions represent Emma's score from the video game example. Equivalent expressions have the same meaning. So as was discussed up front, are they both right? Yes. They're both equivalent. They both represent the same thing. Two expressions are considered equivalent when a substitution of any number for the unknown P in each of the expressions produces the same numerical result. That was the part that I just had you skip. We know that they're equivalent because we could have substituted in P is 700 for each one of these, and each one of them would have given us the result of 3,100. Thank you for your trust on that so that we could save some time. Substituting, and we're going to highlight this part, substituting in a specific number for an unknown in an expression is called evaluating the expression. So I said, hey, I know what P is. P is 700. That's what is considered evaluating. And finally, our last definition. For ease of communicating mathematical ideas, we will consider a linear expression of the form ax plus b, where a and b are just numbers. X represents an unknown. This is the simplified form of a linear expression. So again, making that connection, what I said earlier, this is going to be a certain number of x tiles. This is going to be a certain number of unit tiles, but notice those are the only tiles we're using. We're not using x squared tiles. We're not using anything larger. It's just going to be a combination of x tiles and unit tiles. Yes, Sam. Once we add an x squared tile, that is considered a quadratic. You're not going to be dealing with quadratics until 10th grade. Okay? Yep. So you're going to be dealing with linear for a couple of years. And here is a quick key. We've already been using our algebra tile, so you already found ways that you can model them. I just want you to understand that as you're looking at this resource, this is the key that they're going to use. Positives are unshaded. So this is our positive unit tile. This is our positive X tile. They look very similar to what we were doing previously. Just know when you see these symbols what they actually mean. Negatives are shaded in. So this is our negative unit tile. This is our negative X tile. Again, shaded in. Also remember, we're going to highlight, sorry, there was one last one that we needed to highlight. Remember that a positive tile and a negative tile can be combined to create a zero pair, which means when added together, they sum to 0. And we can go through these next parts really quickly because of the time that we spent the last couple days simplifying expressions by combining like terms, and then the next example of using the distributive property. This is a model of the expression 5x plus a negative 3x minus 6 plus 4. You can see how they're matching. 5 positive x tiles, 3 negative x tiles, 6 negative unit tiles, because what they did is they changed this subtraction to adding a negative. So we're representing that with 6 negative unit tiles and 4 positive unit tiles. Their first step, find the zero pairs and write the simplified form of this expression. Here's some zero pairs. Here's some more zero pairs. Once we have found those zero pairs, what is this really? We have 1, 2 positive x tiles and 1, 2 negative unit tiles. So 2x minus 2. Always. And I'm not always going to remind you that this can be rewritten to be adding a negative. I want you to start making that connection on your own. But the answer is yes. This subtraction can be rewritten as adding a negative. You always have that option. Good question. Evaluate this expression when x equals 8. So it doesn't matter if you wrote this version or this version. We are evaluating, which means I now am knowing that the x value is 8. So I substitute that in, and I have 2 groups of 8, or 2 times 8, minus 2. We need to simplify according to the order of operations, which means, yes, there's grouping symbols, but the reason I put those grouping symbols in is because I was substituting the value in. So those grouping symbols are really there because of the multiplication that's happening. So grouping symbols, which really are for the multiplication. No exponent, so I can jump ahead to that multiplication. 2 times 8 is 16. 16 minus 2 simplifies to 14. So we evaluated this expression when x equals 8, and the result is 14. And now it's your turn. Using your tiles, which I'm not going to get out the tiles, but you can draw your model. Please model the expression negative 4x plus 3 plus 5x plus negative 1. Simplify it. Find those zero pairs, combine the like terms, and then evaluate the expression when x is equal to negative 5. You can even move on to the next one because we also have this practice with distribution. 3 groups of x plus 1. You can see how it's modeled. Write the simplified form of this expression and evaluate when x equals negative 4. You can even move on to number 5, where now, instead of having an example, you are drawing the model out yourself. So, through 5, you guys can complete those with your groups. This should take you roughly, if you're on task the entire time, 2.5 minutes. But I want you to get through problem 5. I'm going to pause the recording now as students work with their groups. Ready, set, go. Okay, number 3, A and B. Here's my model. You can see I'm using color, so I'm not drawing the full rectangle. My negative 4x tiles, 3 positive unit tiles, 5 green positive x tiles, and 1 negative unit tile. I didn't move them around because I was trying to mimic what you guys would be able to do drawing it. But you can see I crossed out these 4 because they zero out these 4. Crossed out this one because it zeroes out this one. That leaves me with the simplified expression x plus 2. Substituting in the value of x equals negative 5, I can evaluate, and negative 5 plus 2 is equal to negative 3. How many zero pairs? Yeah, 5. Yeah, 4 zero pairs of the x's and a 5th one in the units. Good job recognizing that. Okay, and this is modeling that distributive property which we practiced last time. So 3 groups of x plus 1. Here's our x plus 1. We have it. 3 different groups. What is the simplified form of this then? We're going to look across the groups and see that there are 3 X tiles, and across the group seeing that there are 3 unit tiles. So the simplified form is 3x plus 3. So when it's time to simplify, or excuse me, time to evaluate the expression x is equal to -4, I'm substituting in this value of -4. Notice how I'm writing that. I don't want it to be confused as 3 minus 4. So I put it in parentheses. That way I see the parentheses and I know that what's really happening in between those is that we're multiplying. Those parentheses are a great tool when we're trying to substitute values. And 3 times -4 simplifies to -12. Plus 3. This evaluates to -9. And last one, 2 groups of 2x minus 1. Here's my 2x. Here's my -1 tile. And I have 2 of those groups. Looking across those groups, I can see that I have a total of 4x tiles. We'll write that down here. And looking across the groups, I can see I have 2 negative unit tiles, so 4x plus a -2, or 4x minus 2 is appropriate. Substituting in x is 0, we have 4 times 0 plus a -2. 4 times 0 simplifies to 0. And 0 plus a -2 is -2. That is it for this video. We will have to continue this in a second video. If you're looking for some extra practice, you can go over these. In our next video, we'll just go over the answers really quick, so you can do this in the meantime to practice. That's it. Thanks for watching.